All right, I'm doing my last edits on this exam, and right now I'm focusing on 3.1. We'll get started with question number 1. Which of the following quantum numbers defines the orientation of an orbital in 3D space? Well, we have 4 quantum numbers. N is your principal quantum number that gives you information about, or you can get that information from the periodic table. So that is going to have a value of 1, 2, 3, 4. Excuse me, L is the shape of the orbital. M sub L is all about the 3D positioning, or the positioning of an orbital in 3D space. M sub S is the magnetic spin quantum number. Okay, so C is the correct answer for that one. That is number 21, C. Number 22, which of the following elements is found in the same period as chlorine on the periodic table? And so when we are talking about a period, we are talking about things being in the same row. A group is a column, and a row is a period. Make some edit there. So oxygen and sulfur and krypton, bromine, and fluorine. Bromine, fluorine are in the same column, so they are in the same group. Sulfur, however, is the only one that's in the same period. So I'm going to highlight that. Booyah. Okay, which of the following statements about quantum numbers is true? N can have a value of 0, 1, 2. L can have a value as low as 1, but no lower. M sub L cannot have a negative value. And L can have a negative value, or or L can be no lower than 0. Okay, so N can have a value of 1, 2, 3, 4. It has to be a positive whole number integer. I'm gonna focus my, where am I? There we go. That's what I wanted to do. Then L can have a value of 0, 1, 2, 3, 4. M sub L can be negative L all the way up to positive L. So the best answer there is answer option D. L can have a negative value. So question number 23 is D. Number 24, the electron configuration for 1s2, 2s2, 2p6. On the base level, that is your notation, your electron configuration for neon. So it is true for all of the following except, well, it's true for neon. O2 minus, well, that's if oxygen gained 2 or more electrons, it's going to have an electron configuration, same as neon. Fluorine needs to gain 1 electron for that configuration. Sodium loses 1 electron, which is why it becomes Na+. Mg, on the other hand, has to lose 2 electrons. So Mg plus is out. It needs to be Mg2 plus. I just ate a bug. I think it flew into my mouth right as I was drinking that. Okay, carrying on. In a Lewis dot structure, what does a triple bond represent between 2 atoms? 1 electron pair, 2 electron pair, 3 electron pairs. C is the correct answer for that. Number 26. What is the molecular geometry with the Vesper notation of AX5? That's going to be trigonal bipyramid or bipyramidal. So D is the correct answer there. Oof. Okay, so 24 was C. 25 is C. 26 is D. Okay, 27. Which statement about bonding is true? A lone pair of electrons occupies the same space as a bonded pair of electrons. That is not true. So a lone pair of electrons is really only bound to 1 nuclei, whereas a shared pair of electrons has 2 nuclei that keep it close. A polar bond has an unequal sharing of electrons. That's true. A nonpolar bond has an unequal sharing of electrons. Well, that's what a polar bond is. And a molecule with a polar bond cannot be polar, or all of these statements are true. Okay. So option one, a lone pair of electrons occupies the same space. Not true. Option C, non-polar bond has an equal sharing of electrons. Unequal sharing of electrons, sorry. Untrue. D, well, if a molecule has a polar bond, it could have, in the case of like carbon dioxide, it has two polar bonds that are directly across from one another, and carbon dioxide is a non-polar molecule. So our best answer for this was B, our definition of a polar bond. All right, I'm going to pause, or I'm going to stop right here, and I'll catch you in the next video.